Hello, everyone. So let me first introduce myself. My name is Swati Trivedi. I'm from New Delhi, and I have done my master's in mathematics from YMCA University that has been located in Haryana. And I'm having the experience of 8 years in teaching as an TGT maths teacher. And since 2 years, I have been teaching as an online tutor. So for today's demo presentation, I have taken the topic circle of class 10th. As you can see on the screen, I have shared. So today we are going to start with the basics of the circles that we have done in our junior classes. Okay, so let's start. The first thing that I would like to tell is about the circle. That everyone know that what is a circle. It's a curved closed figure that we have learned. So it's a curved closed figure which is having a fixed center and infinite number of radius it is having, and the diameter which is known as to be the largest chord of the circle. Okay. So, but as we know, we are in the 10th class. So in the 10th class, we have just learned about the circle, and we have learned about the in the 9th as well. So what the concept we have learned in the 9th class, that first of all we are going to discuss, then we will come to the main concept of the class 10th. Okay. As you can see, the definition of the circle is all the points in a given distance from a central point in a plane is named by the center, and this is the concept we learned, that how the circle has been formed. Then we talk about the radius. As you all know, the radius is the distance from the center of a circle to the edge, that is known as the radius. And the chord, line segment, it's a line segment which connects 2 points on a circle. Here you can see the figure. We are having, this is our center that I told you in the beginning of the class, that the center means it's a fixed point. Okay. After that, what we can say, radius. It has been from the starting point is from center, and it's been having the another point on the circumference of the circle. Then diameter. As you all know, the diameter is twice of the radius, and chord, which is always below the center. Okay. So these all this concept we know already in our junior classes. Now, the most important thing that you should know is your secant and tangent. What is in secant? The line that intersects a circle twice. A line is passing, as you can see in the figure, and this line passes and intersect the circle twice. So how it is touching the circle twice? This is the point, if I'm considering is at the P, and this is the point I'm going to consider it as a Q. Okay. Then comes our tangent. Basically, the chapter is based on this concept of the tangent. The tangent is the line that intersect once, but it touches the circumference of the circle, as you can see in the figure. B point is the point of tangency, and the line which is passing, touching at a particular point, that is known as to be the tangent that has been shown in the figure. So these are very basic concept that you have learned, and the most important one is our tangent that you should know. And if I'm talking about the point of contact, tangent have infinite point of contact. From one point, the tangent can pass infinite times. That is also the main concept that you should know about the tangent. Okay. Till here, I don't think so you may have any doubt. The next thing. Now, as you know that we are going to learn about the circle, before that, before solving the problems, we should know the theorems. There are two most important theorems this chapter. Theorem number 10.1, that is related to the tangent again, and the theorem 10.2, as I can show you. This one, theorem 10.2, the length of the tangent. It is again related to the tangent concept, and the two theorems on which the whole chapter has been based, and we are going to solve these questions. Clear? So let's start. with the theorem 10.1. So let's read with the statement of this theorem, and then we are going to do the proof of that particular thing. Okay. What is your 10.1 says that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Again, we are going to read out this one, the tangent, which passes outside and touches the circumference of a circle at a particular point. The tangent at any point of a circle is always perpendicular, to which it has been perpendicular to the radius to the point of contact. So which means that whatever the tangent we are having is perpendicular to that particular point as a radius. Okay. Till here, any doubt? No. So as you can see, we are having a circle, and on that circle, we are having a tangent which is passing, and the point of contact, as you can see, it's P. And what is our radius? Our radius is as a OP. Okay. And the line of the tangent is as a X and Y. So here first of all, what we are going to do? First of all, we are going to write the given. Okay. Take any point, take any point Q on XY and join OQ. This is the step of construction. In the given, what we can write? We can write that circle is given with a center O and tangent is passing as a line XY. Okay. So the construction, what we have done, we have to join, as you can see, the dotted line, that is our OQ. And what we are going to prove here? We are going to prove that XY that is our tangent, XY is perpendicular to OP. So let's start with the proof. So let us take a proof. Suppose OQ meets the circle at B point. OQ, as you can see, we are going to consider this as a point. We are going to consider this as a point B. Okay. Now, so you know that radius we are having, so we can say now from the figure, we can say that OP is equals to OB because both are the radius. This one, OP and OB, both are the radius of the circle. So we can write, and as you know that OQ, how I can write? OB plus BQ. Okay. So as we know that we can write as a OB plus BQ. So which means that, as you can see, that in the place of OB, I can write as OP also because both are the radius of the circle. We know that already we have done that OP is equals to OB. So we can write as in the place of OB as a OP and plus BQ. That is equals to OQ. So which means that OQ will be greater than OP because with the addition of the OP we are getting now. So which means that OQ line is greater than the OP line. Till here, anyone has the doubt? No. So no confusion you are having here. So till here, all the concepts are been clear. Okay. So now the next thing what we are going to discuss is that what we have been proved, we have just proved that OQ is greater than OP. This is the thing. Okay. Which means that OP is a shorter than any other line segment joining the point O to any point on tangent. What we have proving that OP is a radius, that is a point of a contact of the tangent and this thing. So it means that OQ is the longer length as compared to the radius OP, which means that any point on this tangent will always be the greater than the OP point. Okay, so you should know one thing, that shortest distance of a point from a given line is always perpendicular to that distance. Okay, so which means that XY is always perpendicular to the OP. The shortest distance is always perpendicular to that given line. So we have basically our concept was to show that the line which is passing from the center is the shortest distance as compared to the line as a tangent which was. So basically we should know one more concept, that whenever the shortest distance is there, it is always perpendicular to the given distance. So this we say that as a hence proved. Okay. So this is the thing that we have done. And thank you for watching this video.